Okay, next step is to make sure that IGP adjacency has actually formed between the internal neighbors, and then look at the LDP neighbors. So maybe this is a problem with IGP transport. Like if I didn't advertise my loopback to you, then you won't be able to form a TCP session to it, and then you won't be able to exchange labels. So from XR2 in the middle's point of view, let's look at the show MPLS LDP neighbors. And LDP is not running. Let's look at show MPLS interfaces. Says LDP is not on. Let's look at the show run router ISIS. It looks like this one didn't have auto config is the issue. MPLS LDP auto config. Okay, if we show MPLS interfaces, now it's enabled. If we show MPLS LDP neighbors, we have the adjacency to 11. And we should also to 13 here shortly. Again, 13, let's look at likewise, same thing. Show MPLS interfaces, and it's not enabled. So let's go under ISIS, address family IPv4, and say MPLS LDP auto config. Okay, and XR2, if we show MPLS LDP neighbors, okay, now both of them are up. Okay, from XR3, when we show MPLS forwarding table, we need to make sure that that outgoing label is not unlabeled. And again, in the case of regular iOS, this would say no label. If it means, if it says either unlabeled or no label, it means it's going to remove the entire label stack, which will ultimately break the end-to-end data plane for the L3VPN customers. Because the problem we'll run into is that there are devices in the core that won't know about the routes of the final destinations. They'll know how to transport the labeled traffic, but only if it does have an actual label or a tag. Okay, so next let's trace to 11, 11, 11, 11. Source is our own loopback. And we can see now this is forming an, going over a label switch path. Okay, next we have our VPN v4 exchange. So we're going to do a peering between XR1 to XR2, XR1 to XR3. XR1 is going to be our VPN v4 route reflector. And then final step will be the VRF config to the customer and then the redistribution. So on XR1, let's say that we're going to run router BGP. And we'll say that we're going to have a, let's use a 4-byte AS number here, and let's say that we have 11.12.13. And we'll say that we are using the actually on XR we don't need to change it. It uses the AS dot notation by default. Okay, so let's say we have 11.13 or 12.13. We're going to have the address family is going to be VPN v4 unicast. The neighbors are going to be 12, 12, 12, 12. Update source is update dash source is loopback 0. Remote AS is the same, 11, 12, 13. Address family is VPN v4 unicast. Okay, then under VPN v4, they are going to be a route reflector client. Okay, if we show config, the neighbor config over to 13 is going to be the same. And then from 12 and 13, we'll have an identical config back to XR1. So neighbor, the other neighbor is going to be 13, 13, 13. And same identical config. This says the instance name is already used. This means BGP is already running. Let's look at the show config. Then let's abort and show run section BGP. Or show run router BGP. Okay, BGP was already enabled here, so this I'm just going to delete. No router BGP1. Okay, same on the other two. Instance name is already in use. This means I need to do this as 2 separate commits. So I need to abort, I need to delete BGP1, commit, then I can paste my new BGP config in and then recommit again. Okay, same thing on the other one. So commit, commit. Then if we look at our full config here, what needs to change is that this is going to go to 11, 11, 11, 11. So again, with these type of core configs, this is the stuff that needs to be second nature within the scope of the lab exam. That you don't have the luxury of the time to be able to reference the documentation for establishing basic IGP, basic LDP, basic BGP peerings. You should be able to get this stuff up as quickly as possible so that when we need to go to our more advanced designs, whether it's L3VPN or maybe carrier supporting carrier, then we have some more time to sit back and relax as we're going through those configs. Okay, final verification we want to look at from XR1's point of view, show BGP, VPN v4 unicast summary, and we see that we have the peers up there. Now notice here it says that the AS number is 722109. This is using the decimal notation. What I want to see here is if it's going to show the AS dot notation. There must be a switch here in XR to change this, the notation. So let's go to the XR configs. And I need to go to, actually, let's go to the command reference here. So reference guide, command references, and then we want BGP. So this will be on our ASR 9K release 5.2, our routing command reference, and then BGP commands. Okay, let's search here for dot. AS-formats AS dot. And this goes under where? Under global config. Okay, so this is just cosmetic. This is kind of like the community's legacy format and then the community new format, which had added the colon in between it. Bitwise, it's the same value. It's just a little bit easier to read when you say the AS format is AS dot. Okay, in the case of regular iOS, this goes under the BGP process, I want to say, router BGP 123, and its BGP AS notation is dot. Okay, so from the other side, we're saying AS format is AS dot globally. So same thing on this guy, and then XR3. Okay, so if we now look at the show BGP, VPN v4 unicast summary, it says the peer in AS11.1213 is up. Okay, so now we're at our last stage, which is we're going to do the routing to the customer, do the redistribution, and then see what happens end to end with the actual routing exchange between the multiple providers. So if we look at first on XR1's point of view, which already had both of these VRFs pre-configured, and let's look at the show run VRF. Okay, right now we have the VRFs defined globally. That's defining their route target import and export policies. But what we don't have is under the BGP process, we need to define what the route distinguisher is. Because even though between the two ASs we're doing regular IPv4 unlabeled routing, so not MPLS, just regular unicast routing, within the AS, we're still running VPN version 4, which means we need to include both the route distinguisher and the route target as part of the BGP attributes. So on XR1, we're going to need to go under router BGP 11.12.13, say VRF A, and specify the route distinguisher. We'll say 100, 100. Then likewise under VRF B, route distinguisher 200, 200. Okay, then we're going to have the VRFs at the link levels. So from XR1, if we look at the show IPv4 VRF all interface brief, we have these pre-configured on gig 0000.411 and 811. Okay, next we need to enable our routing processes that are going to go to these neighbors. So we're going to have OSPF, we'll say router OSPF2, and the VRF is A, and the interface is this one here. Okay, that's going to go under area 0. This is the link we're running it on. Okay, we then have EHRP. So let's say we have router EHRP B. Address family is IPv4. Actually, no, just the VRF. VRF is B. And the interface, gig 00000811. Okay, also the and that's under the wrong mode. Okay, let me go back. I need to go to EHRP. I need to go to the VRF, and then under here I should have gone to the address family, IPv4. Okay, then I could specify the interface. And again, you have to be careful with this in terms of iOS XR, that you need to pay close attention to what modes are you moving between, because there's a lot of overlapping configs in terms of global versus under the routing process. And if I had left it where it was, the result was that EHRP would not have been enabled. But if you're not looking at it carefully, you can see it drops out of EHRP under the sub interface. Okay, now if I paste this in again, paste it in again, we should go to the interface under the AF under EHRP. Okay, so now we'll commit, and I think I forgot to call the autonomous system. Let's say do show run router EHRP. Yeah, so under VRFB, I need to say the autonomous system was under the address family, IPv4. Autonomous system was number 10 in this case. Okay, so now let's look at the routing. From XR1's point of view, we should be able to receive the OSPF routes from router 4, the EHRP routes in from router 8 in their VRFs respectively. So again, we're going to look at the show route. What's the VRF name? It's VRF A. And what address family? It's IPv4 unicast. Then likewise show route VRFB, IPv4 unicast. Okay, we have the OSPF and EHRP routes respectively. Next, we need to enable the VRFs on XR3. So from XR1, let's look at just the show run. And we're going to copy some of this out that's related to the VRF config, because it's going to be the same config we need to put on XR3. So we need to keep the VRF definitions. We're then going to have our new interfaces. So the interfaces where previously we had these ones. So these are now going to change to, we'll say it's gig 1313 is going to be .1Q 1313. Okay, IP address IPv4 is 10.13.13.13 actually. Okay, the other one is 23.13, which is in VRFB. Okay, then we have under the BGP process, we need to specify our route distinguishers. So we have VRF-A, we have VRF-B, and then we commit. Okay, once this is done, we can then test direct connectivity between router 3 and XR3 and make sure they can reach each other on those inter-AS links. So on XR3, let's look at the show IPv4 VRF all interface brief. And we see we have the two inter-AS links that are in VRFs A and B respectively. So we now want to see, can we reach the other end? So we'll ping 10.13.13.3 in VRF A. And ping 10.23.13.3 in VRFB. Okay, so both of them we have connectivity to. Next, we need to decide how are we specifically going to do the inter-AS exchange in terms of which routing protocol. Now, as we looked at previously in the intra-AS L3VPN, we saw that the different PE to CE routing protocols have different loop prevention mechanisms, and they have some different behaviors in terms of the route type encoding. One of the examples we saw previously is when we were dealing with OSPF, that when a route came in this side and the route was intra-area, so an O route, and it went out to the other site that had the same OSPF domain ID encoding, the end result is that the route appeared as inter-area, as OIA. Now, additionally, in that OIA route, we were setting the OSPF downward bit, or the DN bit, in the database, which is part of the loop prevention mechanism. But as we saw that when we have different types of PE to CE routing protocols, the information that is normally encoded as a BGP extended community would get stripped if we have OSPF on one side and EHRP on the other side. And this is, in terms of path selection and loop prevention, one of the big considerations for inter-AS option A. That if we're going to be running BGP now between router 3 and router 13, we're going to lose the encoding of the VPN v4 attributes, and we could potentially cause a loop when we're going into OSPF or when we're going into EHRP. Now, we can specifically reset those attributes, but in this example, I'm going to leave them as the default behavior, which should be that they are removed. And then we want to see how this is going to affect either the EHRP or the OSPF routing. So in other words, we need to make sure that we're doing two separate BGP peerings. One of them is going to be for VRF-A, and another BGP peering is going to be for VRF-B. So on router 3, if we look at the show run section BGP, we're going to say that under BGP 123, under the address family IPv4 VRF-A, we have a neighbor that is 10.13.13.13. Remote AS is 11.12.13. Okay, then in VRF-B, we have the same AS, but we have a different IP address because they're in two separate routing tables. Okay, then we have to do our redistribution. So on router 3, if we look at the show IP route VRF star, we are routing OSPF locally in table A. Okay, so we were under BGP. We then went to VRF-A, and we're going to say redistribute OSPF 2. Under OSPF 2, we're going to redistribute BGP 123 subnets. Okay, we also need redistribution on router 2. So on router 2, if we look at the show run section router, we have EHRP-B under the address family. And then under the topology base, I think this goes. Redistribute BGP 123, and we'll give it a metric value. Okay, under BGP 123, address family is IPv4 VRF-B, and we're redistributing EHRP, and autonomous system is what, 10. Okay, from router 2's point of view, if we now look at the show BGP, VPN v4 unicast all, we should see that the local routes that we learned from IGP from the customer are now getting installed in the BGP table as VPN v4 routes. Or in other words, we did the redistribution. Okay, same thing is going to be true on router 3. From router 3's point of view, we should have done the OSPF to BGP redistribution, and we should see the routes that are coming in from router 2 as well. If we now look at the show IP route VRF star, we should see that we're importing these routes locally. So for table A, we have the OSPF routes that came from our local customer, but for table B, we have the BGP routes that were coming from VPN v4. Okay, this means that if we go to the other end on XR3, and we're likewise going to configure two BGP peerings, once this is done, we should be receiving the routes that are included in A and in B. Now, since we're peering eBGP here on iOS XR, what's one of the other considerations that we need to configure? So if we look at the show run router BGP, we're going to go under VRF-A in configuring a peer to router 3, and then likewise under VRF-B, but we'll also need to do what? Okay, so let's go to BGP 11, 12, 13. VRF is A. Address family is IPv4 unicast, so that's turning it on. The neighbor is then going to be 10, 13, 13, 3. Their remote AS is 1, 2, 3. Okay, the other option, like a couple people mentioned here, is the routing policy language. So we need to say, as we have the route policy going outbound to them, coming inbound from them, we need to pass the routes. So we need to now create a policy, or let's say show run or show RPL. Do show RPL. And we don't have a policy, so we need to say route policy pass, pass. Okay, then we jump back to the neighbor. The neighbor under the, so exit out of there first, jump back to the neighbor, to the address family under the neighbor, and then the route policy pass gets applied outbound and inbound. Okay, so this we essentially need to do this twice now. We need to do it under VRF-A, and we need to do it under VRF-B. So we have the address family, we have the neighbor, 10, 10, 23, 13, 3, and then the rest of this is the same. So you can see a lot of this config is very repetitive, but there's so many different places that you can make a minor mistake that's going to break the entire end-to-end design. That's why we have to know how do we verify each individual piece as we build the entire design. You can't just figure, I'm going to start on one end, configure everything, go to the next router and continue to do that. You're much more likely to make some sort of minor mistake that's going to break something overall. Okay, so next on XR3, let's look at the show BGP. The VRF is A. What type of neighbor is it? IPv4 unicast. We want to look at the summary. Okay, we're receiving routes in from router 3. Should be same for VRF-B. Okay, these routes should be advertised over to XR1. On XR1, if we now look at the show BGP, VRF-A, IPv4 unicast. It says none of the requested address families are configured for the instance default. This means that we didn't do the redistribution yet from the IGB processes into the BGP process, because that's when we would be enabling that address family, is when we redistribute IGB into BGP. So if we look at the show run router, or show run router BGP, we need to say under BGP 1213, under the VRF, we have the address family, and we're going to then redistribute what protocol? In VRF-A, we're running OSPF. Okay, so in this case, it's OSPF2. Under VRF-B, we're redistribute EIGRP10. Okay, if we then look at the show BGP, VPN v4 unicast, we should see that we are originating locally these routes. But we still have one last step, which is the redistribution the other way. So we went from the customer into BGP, we need to go from the BGP back to the customer. So if we look at the show run router OSPF, this is going to be under the VRF. We're going to redistribute BGP 111213. Show run router EIGRP, same thing. Under that address family, redistribute BGP 111213. And in this case, for XR, we're going to need to call a route policy. Okay, for right now, I'm going to leave this alone and show what the potential problem is. That if we now go to, and actually it does tell you this when you're from a log message. It says there's no routing, there's no metric that was set at redistribution. In our previous examples, this was not a problem because why? So we redistributed from EIGRP into BGP, then BGP back into EIGRP, but we didn't need to set a metric because the metrics were encoded in the VPN v4 update. The issue now would be if we were to look at the show BGP VPN v4 unicast for VRFB, and let's pick an individual route. Let's pick 8888/32. Okay, this one you can see it does have the EIGRP extended communities, or in other words, the BGP cost community. It's copying the EIGRP vector attributes into BGP so that it's going to keep those as internal EIGRP routes end to end. But if we look at the route that came from the other side, which was 10.10.10.10, this is just a native IPv4 route as it went between the edge devices. So the extended communities, it's not encoding that anymore. This means that when we go to the final customer, like router 8 and show IP route, we're not going to be able to install those prefixes because they cannot get encoded into the EIGRP topology table unless there's some variable for the metrics. And you can see the box does try to help you out because it generates the log message. But the issue is that if logging is off, it's easy to miss this. So in the case of iOS XR, we need to create a route policy, and I'll call this my EIGRP metric. It's going to set the EIGRP metric. We'll give it the bandwidth, the delay, reliability, loading, and then the MTU. Okay, if we show config, let's say show config, do show config, commit changes last one. Okay, this is my last commit was I need to go under EIGRP, and when I'm doing the redistribution, I need to say redistribute BGP, but use the route policy, and now I'm calling it EIGRP metric. Okay, that was the missing piece. Okay, now let's finally look at this from the end customers. So if we show IP route, the end customers, specifically in our case, are 7, 10, 4, and 8. Okay, we should be getting connectivity between 4 and 7, and then between 8 and 10. So let's go to router 4, and router 4 should have 7777, which it does. But notice here the way that it was encoded as OSPF external, not as OSPF inter-area, because the VPN v4 attributes were lost as we did the redistribution between VRF, BGP, IPv4 unicast, and the OSPF process. Okay, the one who was stripping it specifically is XR3. So if we do a ping to 7777, we'll source this from our own loopback. We have connectivity. Okay, let's look from router 8's point of view. We see we have 10.10.10.10. It's an external EIGRP route because we lost the encoding for EIGRP. And if we ping to 10.10.10.10, source from 8888, we have reachability.